Good afternoon, everybody. It sure feels good to be in person to a fully packed reInvent like the pre-COVID days. So thank you all for coming. I'm Ishwar Parulkar, technologist in the telecom BU in AWS. And with me today speaking is Samir Buyuru, who's the Director of Business Development in the telecom BU. In AWS, we are focusing on a few strategic areas, a handful of strategic areas, where we have created dedicated business units because we feel these industries are strategic as well as require custom focus in terms of building services as well as go-to-market motions. And telecom is one of them. That's what the telecom BU is about. And as part of what we do in the BU, the business unit, telecoms or communication service providers are our customers. So we build services for them, but they're also our partners. So we co-invent with them and go jointly to market on some of the offerings. And today's talk is about the latter piece, about how we co-invent with them with a couple of new services that we announced earlier this year. So basically, in this talk, first I'll go over the value of the cloud in networks and connectivity, why we think cloud is a big enabler in this space. And then we'll go over the connectivity services. As I said, the focus is really on AWS Private 5G and Cloud WAN, which we released earlier this year. But I did want to touch very briefly on Direct Connect, which was launched several years earlier, but kind of set the precedence for this philosophy we have, where we build some offerings for enterprises based on our learnings from enterprise customers, where we think we can add value. But then we work with CSPs or communication service providers to really evolve or enhance or build the service together. And then following that, Samir will talk specifically about how we are co-inventing with these two services, some of the deployment, the success stories, and some use cases that we see. So why cloud? What is the role of the cloud in networks and connectivity? So if you look at it at a very high level, the cloud is global large-scale infrastructure and multi-tenanted. What that gives is elasticity. Users can use resources when they want it and relinquish when they don't want it, giving them the perception of having infinite capacity. Elasticity enables new consumption models, new pricing models like pay-as-you-go. You don't need to pay for everything upfront. You pay for what you use. As you use more, you pay more. The cloud fundamentally is highly available, secure, and reliable. There's an automation in how we operate the cloud. We put in patches, software patches, security upgrades, patches 24/7, any time of the day, without bringing down any customer or bringing down any part of the infrastructure. And most importantly, it gives agility. You can build new services, new applications very quickly. You can innovate, experiment, refine, and really change the customer experience very rapidly. And what we want to do here is bring that value to networks. All of these characteristics of the cloud to networks. And we're looking at all types of networks, from mobile networks, private networks, wired, cable, broadband, and backbone. And so that's what it's all about, bringing this value of the cloud. Because if you look at it, networks are also large-scale infrastructure, multi-tenanted, multi-user. So, it's a natural thing to look at. And while the value of the cloud has stayed constant since the inception of the cloud, the capabilities have evolved over time. And I wanted to give you a sense of how the journey of the cloud has evolved in terms of what we do, because that ties directly to how we are offering these new services in partnership with CSPs. So the cloud started with filling a skill gap. It was basically just making it simpler for developers to carve out virtual infrastructure, create instances, and get up and running. As we got traction in this, as there were more developers, we realized there were a lot of applications that already existed that had to be moved to the cloud. And so we focused on migration. How do we migrate legacy application? We built specific services, architectures, trainings to enable migration of legacy applications. As the service portfolio grew, we realized there were several use cases which required stitching of multiple services into solutions. And so we started building solutions, pre-built solutions that we could offer to our customers. So this is a combination of existing services stitched together to really solve a problem. We also realized certain patterns in how developers were using our services. For example, they wanted databases that they could add objects and the database would grow on its own. They needed monitoring along with that. So we chose certain areas where we build managed services where all of this comes together. So the developers don't have to cobble together a way of resizing the database as the objects grow. It just happens automatically. So that's managed services. And when we are building these connectivity services and working with our partners, you will see this mirrored. There are managed services that we build because we see value in AWS managing and help, kind of taking the friction out from our customers. And then there are solutions which we build with our partners, CSPs as partners, where the combination of things that come together, some assets from us, some assets from our CSPs. So let's look at the precedents to this, and this happened years ago. We have Direct Connect, which is a very mature service, launched in 2011, actually. And it's basically a private, secure, reliable, and scalable point-to-point network from a enterprise customer's location, data center, or an on-prem location to the cloud. It's dedicated connectivity to the cloud. And it basically lowers the cost for them. It's private. And it guarantees SLAs which are not possible on the open internet. So that's the simple value proposition we had on Direct Connect. And this is how the architecture looks like. You have the customer's corporate data center, number one, connected over a last mile, number two, to an AWS Direct Connect location. In the Direct Connect location, you have routers or devices or cages that are owned by the customer that the last mile connects to, number three. And then there's over cross-connect, number four, a simple cross-connect, it connects to AWS devices or cages or routers. And those AWS devices connect to the cloud directly over the backbone. So that's the straightforward architecture. But the CSPs have played a very, very big role in helping us deliver this service. And there's different levels at how we are partnered with CSPs. So one is the simple CSP's role of providing the last mile connectivity. They do that today. That's what they do in this case. Then we have CSPs who have inducted into the partner network, and they have expertise in delivering this Direct Connect, and they add some more components like the cross connect and maybe the customer side routers and cages. And then there's reseller. There are some CSPs who can actually resell the service as well. So if you see this service, which is now very mature, we have multiple options in which how we partnered with CSPs. And there's many of these today as partners for Direct Connect across the globe. And these are tier 1, tier 2 CSPs. These are colo houses, and so forth. And the purpose of going over Direct Connect was to just show you the philosophy that we have kind of adhered to over the years, which is build an enterprise connectivity service, but then really engage with CSP partners to deliver it. And the same philosophy carries over to 2 new services that we announced earlier this year. So the first one is AWS Private 5G. This is private networks. This is an AWS managed service which builds private networks for enterprise customers. Before we get into it, I wanted to step back and see why private networks, why the cloud in building private networks. What is the value there? And this is how we see the evolution of mobile networks. If you see, typically people talk about the evolution in terms of either generations, 1G, 2G to 5G, or in terms of devices, analog phones, mobile phones, smartphones, etc. The way I like to look at it is from a killer app perspective. What was the killer app that drove that transition in networks? That was the underpinning of all the technology that had to be developed and the use cases that came about. So if you look at it, step back, the killer app for the first couple of generations was simple connectivity, connecting individuals to each other, connecting devices to each other, connecting individuals to devices. So connectivity was the killer app. The next generations were about data. Data was the killer app. Video, over-the-top applications that required massive amounts of data to be moved across the network. That drove a lot of the technology and the devices in the network evolution. We are at a point now with 5G and going ahead where the killer app is really network as an application. We are seeing cases, use cases, and the potential for offering the network itself as an application. And there are several of these use cases, starting from smart factories, smart energy management, transportation, smart devices. There's a whole plethora of these use cases that you must be familiar about. And Samir will later talk about some of the specific deployments and use cases that kind of we have done. So the market for this is estimated to be 8.6 billion in 2026 according to IDC. And they categorize it into two types of enterprise customers. There are the small, medium business customers. The deployments are smaller. The topology is simpler, a few access points. And then there are the larger enterprise businesses. These are oil rigs, stadiums, campuses. And we have different solutions, different approaches for this. So for the large enterprises where you need many access points, there's density of radio coverage, there's some complexity involved in building up the network and managing it. We do what I call the do-it-yourself approach, which is essentially integrating multiple AWS services to create a private network. This is either done by an ISV or by an SI, system integrator, or us, and managed as well by either the ISV or the system integrator. For the smaller enterprises, we launched a service called AWS Private 5G, and this is a fully managed AWS managed service where you can deploy, operate, and scale a private network in a small on-prem scenario. And how that works is basically the enterprise customer, using just a few clicks in the API console, mentions how much capacity and coverage is required, the geographical profile of the site, and equipment, the hardware required to build the network, and power and internet is delivered by AWS to the enterprise customer. This is then installed there, obviously by a partner who can be physically present there. And then through the console, this service is activated, and you pay as much as needed in the beginning. You don't have to, there's no fixed pricing. You start with what you need, you pay for that, and then you scale over time. The network is managed completely in the cloud. You have dashboards and you have ways of monitoring the network in the cloud. And basically, the network is treated like an AWS resource, like any other AWS resource. And lastly, you can scale as you need. So when you need more throughput, you scale up the network. And when you don't need it, you kind of scale it down. So this is basically the approach we have in terms of how the network is deployed and operated. So this is completely frictionless for the customers. You don't have to pay any upfront device cost. And we also changed the pricing model. We brought the cloud consumption and pricing model to these networks. So if you now map it to what is really the value proposition here, what does the cloud really bring that is different than a network that's built in other ways? So one is hassle-free procurement of the hardware required. Through just few API calls, you can figure out what's needed, and that gets shipped and deployed and then installed. The next one is starting small as a business and then scaling as needed. This is, again, the fundamental value proposition of the cloud. Then we're changing the pricing model, again, bringing more of the cloud consumption and pricing model, which is pay as you go, and also pay only for throughput, not per devices. So you pay based on the throughput that is needed and required and used by the devices. It also comes integrated with the AWS services. And that's the other difference between building a private network using just servers or hardware appliances from other third party versus using the cloud to build the private network. It comes with not only just basic services like identity access management, but other services like machine learning, our machine learning stack, which is what you need really to build applications on top of those networks. And lastly, it has the same pace of innovation. So again, unlike isolated servers that might be sitting in an on-prem environment, this is really bringing the cloud to the edge So anything that we do in the region in terms of new services, upgrades to services, enhancements, get reflected in the edge network. So that was private 5G. The second service we announced is AWS Cloud WAN, and this was again announced earlier this year. So again, before getting into Cloud WAN, what Cloud WAN is, I wanted to take a step back to really go over how WAN has evolved over the last few years. And this here is what a traditional WAN looks like even in certain parts of the world with certain operators today. You have branch offices, remote branch offices. With large enterprises, there are multiple of these. Think of banks, bank branches, all connected to a corporate data center or multiple corporate data centers. These are usually one per metro, few per metro, depending on the enterprise. And typically, applications, users are in these branch locations, applications are in the data center. The connectivity typically is VPN or MPLS. For the non-telco folks in the audience, MPLS stands for multi-protocol label switching. It's a protocol which uses labels instead of source destination IP addresses. And the benefit of that is scale, performance, reliability, being able to get to higher bandwidth utilization, reduce network congestion, and so forth. So there are many benefits to that, using that protocol. That's why it's used. However, it's expensive. It is static and not as flexible. So those are the cons of using the protocol. But MPLS is still very prevalent. But as you can see, because it's static and inflexible, any new office that needs to come online takes months. Geographies take even longer. If you wanted to add like a new area, metro area, or a new country for that matter, to a global network, takes a lot longer. Now, a lot of changes happened in the recent years for the WAN architecture to change. The first thing is apps moved to the cloud. So instead of apps in the corporate data centers, they are now in the cloud. Those cloud regions require peering if you want to really use those applications. So that means going over the internet to the cloud, which brought complexity of management of the network. It brought unpredictable application behavior and data vulnerability. So these were the challenges that needed to be solved, which necessitated a need for a new WAN architecture. And this coupled with what I mentioned earlier, which is that the traditional WAN was expensive, static, and inflexible. So that created a shift in terms of how WAN architectures were being deployed. The other trend that happened a few years ago was software-defined networking. Started in routing, which was separating the data and control plane, creating a central controller to manage routing. And the same trend and principle applied to WAN, to create software-defined WAN, or SD-WAN. Now, SD-WAN is a virtual abstraction layer where you have a central controller that can program a network fabric. And because it's centralized controller and software-driven, you can do things like zero-touch provisioning, on-demand bandwidth provisioning. A lot of security policies can be implemented along with the SD-WAN controller. So there are many advantages to that, and it's very dynamic and flexible. So that's what the modern WAN looks like today, where operators have been able to get to this stage. So we took advantage of these strengths and took it one step further to build Cloud WAN. Now, AWS Cloud WAN is a fully managed AWS service to create a global wide area network that connects remote locations, corporate data centers of customers, and the cloud. And it's fully managed. Customers can bring any type of connectivity they have from their side. It could be a VPN, it could be SD-WAN links, it could be Direct Connect, which I talked about earlier. And that gets connected through the Cloud WAN fabric to VPCs in our different regions. This uses the AWS backbone. So that's the other key part of AWS Cloud WAN is we actually have backbone assets that connect regions. These are very high-speed, low-latency, redundant connections. So those come into play here, and customers can take advantage of that in building their WAN fabric. Then we have, again, a centralized controller that allows for programming of policies, and these policies can be used to program, to do routing configurations, apply security rules, as well as add other applications for creating a secure edge. So this is what AWS Cloud WAN essentially is. And basically how it works, looking at it from a customer perspective, the enterprise customer, brings network resources that they already have. These could be from another CSP, or they could be their own resources. And as I mentioned, there's a whole bunch of options here. They could be Direct Connect, they could be site-to-site VPN, which are AWS services, but they could have their own SD-WAN network. So these are the resources they come with. And then through the AWS console, they can build, manage, and operate a global WAN network. Along with Cloud WAN, there's a central dashboard, which is a very key part of the service. And that allows the customers to create all kinds of topologies with these type of connections. So they can create topologies with their branch offices, data centers, and VPCs in the region. They can also monitor events and performance through the dashboard. And then, as I mentioned, there's a policy engine that enables them to apply policies, program and apply policies for things like routing, security, segmentation, isolation, etc. So this way, customers can create a unified, centrally managed network across not only one geography, but multiple geographies across the globe. And the value proposition of the cloud is pretty straightforward here, right? You can build a global network in minutes, firstly. As I mentioned earlier, traditional WANs take months, sometimes even more than that when you talk about expanded geographies. But in this, with AWS Cloud WAN, you can build a global network literally in minutes. The second key asset that comes with it is the backbone. So we have a global backbone, and that is part of Cloud WAN. It also simplifies WAN networking greatly. If you look at the architecture diagrams I showed earlier about traditional WANs and also the modern WAN, there's a lot of components that go in there that need to be configured and programmed to make it work. Here, we take that friction out from the customer's hands and really simplify the overall networking. Then you can do things like segment the traffic, apply security policies, and also you get very advanced visibility because of the dashboards. We have put in special hooks to get more visibility into the network, which helps manage the networking complexity as well as debug problems, figure out where congestion is, where you need capacity, and so forth. So there's a lot of visibility also built into the service. So these are basically the two new services, connectivity services. We started looking at these from the perspective of what enterprise needed, and these were kind of launched middle of last year. There are other sessions where you will get more details on the services, but I'll hand it over to my colleague Samir, who's going to talk a little more about what we are doing with CSPs with these two services. Samir, over to you.
Thanks, Ishwar. Thanks for the great introduction. Wanted to start off with a quote, right, from someone who's been associated with Amazon in the past, and it's still our executive chairman. Every new thing creates a lot of questions. It's not just two, but it creates a lot of opportunity as well. And we're really pleased to walk you through how our telco partners, our CSP partners, are actually using these new services that we've announced to either augment or improve or create new markets together, right? So let's start off with a view of the market itself, right? So This is something that Analysis Mason and Forrester have created for us. When they did an analysis of where the value lay in actually connectivity-enabled enterprises, right? And so if you look at the pure connectivity services, they represent about 10% of the total opportunity that a typical enterprise consumes, right? And we have actually seen over the course of 200 plus deployments that that number actually does hold true. And so the fundamental part of our approach to partnering with CSPs is how do we grow business together, right? How do we create this virtuous cycle? And so what we are starting to see is that if you make it easy to deploy the applications, the value-added software, if you make it easy to procure the end-to-end integration services, and you simplify operations, you essentially end up capturing the other 65% of the market that I show in the box on the right-hand side, right? And so historically, this has been hampered by very difficult procurement processes, lack of elasticity, the availability to go global in minutes, everything that Ishwar talked about earlier. And so that is the fundamental problem and opportunity that we're addressing with not just these two services, but a lot of other services with our telco customers. So let's go into examples, right? What are we actually doing on AWS Private 5G with our CSP partners? So here's the opportunities, right? Once you simplify the procurement and the scaling, the billing of private cellular networks, it opens up a lot of opportunities for our partners. Licensed spectrum, with the exception of a few regions like the United States where CBRS is prevalent, you cannot operate these networks without the spectrum, right? And how quickly, how efficiently can you monetize that spectrum is what we're really trying to solve here. The RF planning, the site deployment, it's critical for enterprises to avoid interference and a lot of regulatory issues that come with that. The ongoing maintenance and support service, right? These are complex deployments that we are trying to simplify. And then how do you actually open up new markets, right? One of the things that we noticed when we launched Private 5G earlier this year in beta is it actually opened up a market of small and medium businesses that wanted to try private cellular networks. In the past, they could not try these because they were hampered by the lack of ease of procurement and the try before you buy aspect of it that we're bringing to the party. So we're actually starting to see this mid and long tail really start to come to the party, which is a different segment, net new segment for private networks. So what have the CSPs who have worked with us started to realize? Remember that 65% that I said was where the applications, the managed services lay? I'm going to show you examples as we go through this as to where CSPs have actually captured that 65% and have grown that business with us. So if you look at the journey, typically, of deploying private networks, right? And you see those dots, you will see that in every single case, it is an AWS and a CSP, right? We cannot do this alone, and we hope to simplify the process for our CSPs. One of the biggest areas is start with the application, the end use, the business outcome required, and work backwards from that in true Amazonian fashion, right? So let's identify the target use case and then really bring this universe of partners, of ISV partners for any vertical that you choose that already run on AWS to come create a solution offering together. Then we will go through an architectural phase together, right? Is it a simple cellular architecture? Do we need cellular plus Wi-Fi? Do we need augmentation with SD-WAN? Many, many different areas. We do a quick functional validation and POC, right? Literally days. We're not talking months of functional validation and POC anymore. Let's see whether this works. And if it works, let's scale it, right? And let's just replicate it, because to try something on the cloud, the cost is very low, right? And if it doesn't work, we will refine it. We will experiment until it works. And that cost of experimentation is so low you can afford to move at scale and at speed. So what have we done with CSPs in the marketplace? I'm going to go through a few of these examples, depending on how much time we have, right? With Spark in New Zealand, for example, where all the waste management infrastructure in Auckland and Wellington right now is being operated on a private network that we have worked on together with Spark. With Rogers in Canada, right, there is an in-venue fan experience where you can actually get real-time statistics, get real-time replays, get 360-degree views of what has happened on your phone. And that's live and working right now. With Etisalat out in the Middle East, it's on-site inspection for hazardous environments, right? As you can imagine, there is a lot of oil and gas refining going on within the Middle East. And in those areas, which are hard to reach, which are remote, which need ruggedized applications, we're starting to see a broad adoption. With, in working with Sacramento, for example, and the California Educational Trust, we have started a program to bridge the digital divide. There is a real impetus from the US government in terms of incentives and in terms of a desire to bridge the education gap for underserved areas, right? Where telcos have historically not been present at scale. But now you can. And we're doing that. And before I move to the second set, I'm going to talk about what is common across all of these, right? There are three things that are common across all of these. One, remoteness of the operation, right? The second one is the ruggedized need for these networks. And the third one is really the ability to act on the data locally without actually transporting it to a central location, right? Because those transport costs are going to get prohibitively expensive as the volume of data increases. So if you see with the waste management area, remote, ruggedized, the hockey in-venue fan experience, terabytes of data that don't need to be transported. On-site inspections in hazardous environments, remote, ruggedized. Broadband access, remote, right? So you see the theme starting to play out and what the real under factors are for scale. With Telenor, we're doing the same thing, connecting rural areas, right? With Verizon, we've deployed private networks in the Corning factory for automation. With Cal Poly, San Luis Obispo, digital divide. And this one's personal because my son actually goes there and he uses that network today, right? And then with DTAC out in Thailand, it's a real-time video-based analytics solutions. A lot of data. So remote, ruggedized, data-intensive is where we're starting to see these private networks start to scale. So let's move on to the other service that Ishwar talked about earlier, which is Cloud WAN. So how are we partnering with CSPs on the transport side, right? So there's a lot of use cases that I will talk through as we go here. The first one is, historically, there were very static solutions in terms of which firewall you used, which SD-WAN provider you used, which SASE client you used when you provided this connectivity, right? Now you can choose from any of the firewall providers, CASB providers, SASE providers, SD-WAN providers that run natively on AWS, right? And you can do that with a click of a button or two on the AWS console and switch out providers as and when you need. The second one is network diversity. For those of you who are familiar with transport contracts and MPLS contracts, historically, it's been an area where, for redundancy purposes, you typically had two providers for your MPLS network. There was a primary provider that carried 70, 80, 90% of your traffic, and then there was a disaster recovery or a backup network that was someone else's network, right? What we're starting to see now is that CSPs continue to go ahead and position the MPLS network, as they should, as the primary. But the AWS Cloud WAN is now being positioned as a truly diverse secondary network. So now you actually capture 100% of the traffic, and the CSP actually operates the Cloud WAN as a managed service on our behalf. And then historically, it was all about managing branches, right? But as these applications move to the cloud, we basically have seen the CSP start to manage the virtual private clouds on AWS, right? As if they were branches, right? That's the analogy here. And so what we're doing with CSPs is we're making Cloud WAN and all the associated services available for them to launch as a managed service, right? For example, if there's a VPC to VPC traffic, the CSP can actually route that over Cloud WAN as if it were a route that the CSP sold to the enterprise, instead of actually hairpinning through MPLS. How does this actually look? I mean, this is exactly what I just discussed, right? You have MPLS as the major network, but you also have AWS Cloud WAN as either a redundant network or a burst capacity network, but someplace where you can host a diversity of these network functions like the CASB, like the firewalls, and so on, right? And provide you that agility to serve the end customer. Then a managed cloud interconnect across multiple different regions, right? You are able to basically have a multi-tenant environment and have the policy set up once on AWS and automated. And then you choose, as the CSP, whether you want to route it via your MPLS network, via Cloud WAN, whether it's an SD-WAN link into the cloud, what kind of VPNs you want to do, and you set it up once, automate it, and you go. The third one is network augmentation, right? think of, I'm going to use a random example, right? Think of a provider in the United States who wants to expand into, I'm going to say Angola in Africa, right? The current process is you go through a bidding process to procure that MPLS link, that long haul or ultra long haul link, right, into Africa somewhere. Then you go do, metro level contracts. Then you go contract with the local provider to provide the last mile. And that whole thing takes months today, right? Now, write the backbone, create a virtual POP as close as you can get to Angola, and all you need to do is deal with the last mile locally, which can be easily procured. And so if you bring it all together, this is a modern global network, right? And what we're basically doing is helping augment how you get to the cloud across multiple different regions as easily, as quickly, and as automated a way as possible. Because the single biggest refrain from our enterprise customers is it's easy to procure compute through AWS. It's easy to procure storage or a database. Please make it easy to procure connectivity and take out the undifferentiated heavy lifting, right? And when we make the network available as a service, we all win. And that's really the message we want to say, right? As we go through on this Cloud WAN journey with you, we have multiple partners. For example, on the SD-WAN side, you have Cisco, you have VMware, you have Palo Alto, you have all the security providers. And this is not comprehensive by any means. You have the system integrators who can put that all together if you so choose. But any communication service provider anywhere in the world can start using this ecosystem today and build with our partners and our native services. With that, I hope I've given you just a glimpse of how cloud is enabling CSP networks and connectivity services. We've launched private 5G and Cloud WAN services. They are being used. But we view the CSP as a key partner to become that managed services provider for us, for these enterprises. And we're learning a lot from our CSP customers and partners, and we're enhancing these services every single day. And we hope that this partnership will yield more efficient ways and simpler ways for enterprise customers to procure both cloud services and connectivity services, and we're starting to see that now. So with that, I wanted to thank you all for your time, for your attention. Ishwar and I will be on the side of the stage. If any of you want to dive deeper with us, have a chat, answer any questions that you may have, talk about next steps. So I look forward to talking to most of you over the next year, and some of you here. All right, thank you.